Okay, party people, here we get to the grand finale. It's not the end, but it's definitely the peak. And so we get to problem number 18, and it is solving a system using Gauss elimination, aka no calculator. Of course, you're welcome to use the calculator to go ahead and get the answer so that you know you're working your way to that direction. But this one does clearly say show each row operation that is used, and of course this is the expectation for the test. I did go ahead and make a quick guide to just kind of help us out, and I'll refer to it as we go along. Now, I will say this is not necessarily appropriate as you climb the ladder of matrices and as you keep learning to solve this. So if you're taking a pre-cal, I wouldn't necessarily hold on to these. This, however, is appropriate for this particular level, and these steps will help you. It's definitely meaty. So let me just show you kind of a rundown of what I did, and of course you're welcome to kind of pause it and take notes from this. There's rules to the game. If you think of it as a game, it does seem to make it go down a little bit easier to get ones, because we need to get ones and zeros. Two options here. We have a row swap, but this is the command that it'll look like. Of course, the A and B will be replaced with which rows you're replacing and you're swapping. The next way to get a 1 is multiply by the reciprocal, and so we have 1 over a random number. Row A will then become the row A. And then you only have one rule to the game to get a 0, which is multiply and add. And so we use a number to multiply it by one row, add it to another row, and that becomes the new and improved row. I do want to mention one little small thing about the row swap. Typically, if you don't use this in your first step, you're not going to use it at all. Again, remember, this is the goal to win. You want your ones diagonal, you want zeros above and below it. And so I did go ahead and I went ahead and wrote down what would the commands go along with the steps. And so step 1, step 2, step 3. Step 4 is to get your 1, step 5, step 6, step 7, step 8, step 9. And then these would the commands that would go along with it. You're replacing, of course, with your numbers. And so again, I'll refer to this as we move along and we progress through this problem, but I just want to go ahead and let you kind of see it in its entirety. And if you want to pause for a minute, you can, of course, take notes and write it down. And so let's go ahead and get started on our matrix. Look here, it is in equation form. We need to put it into the matrix. So let's go ahead and start with that. Make sure you're really careful here. If you copy one number wrong in the beginning, well, you've essentially cost yourself the whole problem. Also, when it's two-digit numbers, be very careful not to write them too close together. I think those might be too close. 1, -3, 8, and 17. And so here we go, we wrote it in the matrix and we're ready to get started. And so this is where I think holding onto the steps is really helpful. Step 1 says you want a 1 right here. Notice we don't have a 1 there, we have a 2. So I did say to get ones, we have some options here. We could do a row swap and that would happen the first step. And we could, that totally makes sense. See how this one is a 1? So we could do a row swap with row 2 becomes row 1 and row 1 becomes row 2. However, something does catch my eye before I just go ahead and go with that. I know that there is another tool to get a 1 here. It's to multiply by the reciprocal. In this case, the reciprocal of 2 would be 1/2. And so that's code for really dividing all of my terms by a 2. And because I noticed that all these are divisible by 2, I'm going to go ahead and use that command because it would at least give me smaller numbers to work with. And it's always easier when your numbers are smaller. So rather than row swapping for my first step, I'm going to be multiplying by the reciprocal of 2, and that's 1/2. So my command is 1/2 row 1 will become the new row 1. And so again, like I said, it's really like dividing all of my terms by a 2. But notice in this command, my row 2 and row 3 don't change. So I'm going to go ahead and lock that in place so that I'm not tempted to want to change that or write down something I'm not supposed to. So all I'm doing is essentially copying from the previous matrix. Now what I'm also going to do is I'm going to show you kind of what happens in my head. I'm going to write down my internal dialogue. All I'm doing is dividing all these by 2. And that becomes my new and improved matrix. So that'd be 1, 5, -13, -28. And so now we're ready to get started on step 2. Again, this helpful guide says that step 2 is to get a 0 here. This is what the command should look like. And so let's come back over here. I want this 1 to become a 0, so the opposite of 1 would be -1 times row 1, because that's the one that has the 1, plus row 2 will be the new and improved row 2. This command says that row 3 and row 1 don't change, so I'm going to go ahead and lock that into place. Again, this is a personal preference, and this is what would happen inside my head. I like to go to the previous matrix, and I like to do my multiplicating and adding, and then bring that new knowledge with me. You can do this in your head. So 1 times -1 would be -1 plus 1 would give me the 0. 5 times -1 would give me -5 plus 8 would give me the 3. And so you get the idea. Or you could always gently above it do your multiplication. So that'd be -1, -5, positive 13, positive 28. And now you're just multiplying those. That's the multiplying and adding part. That is what I would write here. And so what would that be? That would be 0, 3, -9, -21. So I'm making progress. I did step 1 and step 2. Now I need to do step 3. Something is really helpful here. Step 3, according to my guide, says I want that to be a 0. Well, they're already opposite. See, the column and the row with the 1 is already opposite of -1. So here my command would just simply be 1 times row 1 plus row 3 will be my new and improved row 3. Row 2, 1 and 2 don't change. I'm going to go ahead and write those in place. Again, be careful on how you copy your elements. And so now what I'm doing is essentially just adding these two up and writing that result in my row 3. I'm going to choose a different color so you can see. That would be 0, 5, minus 3 would be 2, -13, plus 8 would give me -5, -28 plus 17 gives me -11. And so now I have step 1, step 2, step 3 done. Step 4 is to get this 3 into a 1. And so I'm going to use my reciprocal. 1/3 row 2 becomes the new row 2. Rows 1 and row 3 don't change. 1, 5, -13, -28. And row 3 doesn't change. 0, 2, -5. -11, and again, remember, whenever we multiply by a reciprocal, all you're really doing is dividing by that number. Again, that's either this work right here that I just wrote is happening in your head, or in your previous matrix, or off to the side. And so 0 divided by positive 3 is still 0. 3 divided by 3 is 1. -9 divided by 3 would give me -3. -21 divided by 3 gives me -7. And so now I have done step 1, step 2, step 3, step 4. Step 5 is to get that 2 into a 0. The opposite of 2 is -2. Row 2, because I just worked really hard to get that 1 right above it, plus row 3 will be the new and improved row 3. And so row 1 and 2 doesn't change. Sorry, row 1 and row 2. Okay, and so now again, this is how I do my work. Everybody has their different preferences. I'm going to go in my previous matrix and multiply all of my row 2 by a -2, and so that would be 0 times -2 is still 0. That would be -2. 3 times -2 would give me a positive 6. 7 times -2 would give me a positive 14. And then this is the number I'm adding. Again, this is happening either in your head or off to the side. And so 0 plus 0 is still 0. -2 plus 2 is 1. Is 0. That's what we wanted, sorry. 6 plus -5 is positive 1. 14 plus -11 would give me a positive 3, and we're definitely making progress here. We have step 1, step 2, step 3, step 4, step 5 done. Now we need to get step 6. The opposite of 5 is -5. Row 2, because that's the one with the 1, plus row 1 will be the new and improved row 1. Row 2 and row 3 do not change, so go ahead and lock them in place. And now I'm going to go to the previous matrix, multiply all of these by -5. 0 times -5 is still 0. 1 times -5 is -5. -3 times -5 would give me a positive 15. -7 times -5 would give me a positive 35. And now I'm adding these numbers. And I'm replacing it with my top row, my new and improved row. And so this is going to give me 1 still. 5 plus -5 is 0. -13 plus 15 would give me a positive 2. -28 plus 35 would give me a positive 7, and now I've done step 1, step 2, step 3, step 4, step 5, step 6. Ah, look what magically happens. Step 7, remember step 7 according to my guide is to make that a 1. This looks like it organically happened. Woohoo, a freebie. And so now we just progress to step 8, which is to make that into a 0. The opposite of negative 3 would be positive 3. Row 3, because that one has the 1, plus row 2 will be the new and improved row 2. And so rows 1 and row 3 don't change. In fact, we definitely don't want to change row 3 because that tells me my Z is, I'm supposed to be writing little lines here. My row 1, 1, 0, 2, 7. And so now again, I'm going to choose to go in my previous matrix and multiply all of my row 3 by a 3. So that's still going to be 0, 0, 3. That would be 3 times 3 would be 9. And now I'm going to add those. 0 plus 0 is still 0. 1 plus 0 is still 1. Negative 3 plus 3 would give me 0. And negative 7 plus 9 would give me 9, 2. 7, 8, 9, yeah, 2. And so now I have my y value. And so I'm so close. I'm one step away, and it's to get that 2 into a 0. So negative 2, because that's the opposite, times the 1. Row 3, because that's where the 1 is. Plus row 1 will be my new and improved row 1. Of course, don't change row 3 and row 2, because that has the answer. And so now I'm going back to my previous matrix. I'm going to multiply all of my row 3 by a negative 2, so that's still 0, 0, negative 2. 3 times negative 2 would give me negative 6, and then those are the numbers I'm adding. And that becomes my new final row 1. And so 1 plus 0 is still 1, 0 plus 0 is still 0, 2 plus negative 2 is 0, 7 plus negative 6 would give me 1, and it looks like my final answer is 1, 2, 3. Of course, you can use your calculator and do RREF to confirm this. We could do that really quick, although this video has been pretty long already. So let's see, let's go second matrix. We're going to go over to edit. It's a 3 by 4 still, and so I'm going to go back up to the beginning here and put my original matrix, which is 2, 10, negative 26, negative 56, 1, 8, negative 22, negative 49, negative 1, negative 3, 8, and 17. I'm going to go second quit. And because this was the last thing I did, I can go second entry. It brings back up the RREF. Let's say that wasn't the case for you. You'd go back into the matrix and you'd go over to math. You'd go up to RREF, hit enter. Then you'd have to go back into the matrix one more time, hit enter, enter, and lo and behold, look, 1, 2, 3, that's exact match. So I did in fact solve this correctly.